here is our gas lab. So we're going to have a total of 5 stations, and this is going to be, it's going to stop you in this video because it is an Edpuzzle. So it's going to give you certain areas where you have to answer questions. And what I would like you to do is answer those questions in the Edpuzzle, but once you answer them, either write them down on paper, okay, or go ahead and type them in your gas lab lab sheet, because this is what will be attached into your notebook is your lab sheet. So you can do 2 things. You can go ahead and do the Edpuzzle. It's going to stop you. It's going to make you do the claims for each one, okay? It's going to make you think about the evidence, and then it's going to ask you what gas law this showed. So it's going to kind of walk you through these 3, but what you can do is you can answer on the Edpuzzle, write your answer down, then go back and enter this into the lab sheet, which you will turn in. You will also get credit for the Edpuzzle. So hopefully this will make it a little bit easier to go ahead and do the lab. Instead of doing it with me, you can do it on your own and make sure that it stops you at the certain points and ask you those questions. All right, so enjoy and get to work. About in your notes, your Boyle's Law, your Charles Law, your Luzak's Law. Well, let's see some of these happen. So the first one I'm going to do is called our crushed can. So this is a way you can actually crush cans without your foot. All right, so let's get started. All right, so we're going to take a can, okay, and I'm going to pour a little bit of water in it, okay. Not too much because I want it to actually heat up pretty fast, okay. And then we're going to go over here to our heat source, and we're going to put that on there, and we're just going to wait a minute so that it starts steaming. Okay, so we'll just let that heat up. It's going to start to boil and steam. Okay, so we are actually boiling, so that's great. So we're boiling. We got that temperature raised of that gases that's in there. We've got a little bit of that vapor coming out, and not only that, but those particles are moving super fast, right? All right, so here we go. What happens when we've increased the temperature so much? Okay, what happens to the pressure? Think about that. And then we're going to go ahead. I'm going to take this, and I'm actually going to dip it straight into the water bath. So let's see what it does. Whoa! Look at that. It totally crushed it. So when I decreased the temperature very rapidly, it got crushed. So what happened? How did that get crushed? Think about it. You know, the pressure of the air outside is always the same. So what happened on the inside when I heated up the temperature? What happened with the pressure? And then when I decreased it super fast, what happened to the temperature? And what caused that can to crush instantly? All right, see you in the next one, station. All right, here's our next station for our gas lab. So remember our 3 laws, right? They relate pressure, temperature, and volume. So I've got the station here called Cartesian Diver. So I'm going to point this down a little bit. So I'm going to see if you guys can see this. Hopefully you guys can. Okay, I would actually like you, let's see, maybe we should get a little bit different angle. So, all right, so let's see if we can get this to work. So here we go. So this is our Cartesian Diver, and you can see that there's a little thing in here. Even if I turn it, it keeps wanting to come towards me. But it's got a level which is about halfway up its little end, okay? And it has air on the top, okay? And it has a little weight thing, and you'll see why in just a minute. So hopefully you can kind of see it. But what's going to happen, you think? I have the cap on, and so what's going to happen is I'm going to squeeze it, okay? And look what's happened. It's gone to the bottom. So then I'm going to let it go, okay? And it comes back up to the top. So think about for a minute, your question is, what is happening inside the bottle? And remember, we're either talking about pressure, volume, or temperature of the gases at the top of the bottle. So when I squeeze it, what am I increasing inside? I'm decreasing the volume, but I'm also increasing what? Okay. But also now our little diver, if you notice at the very top, he's got some air. Watch what happens. Hopefully you guys can see it. Watch what happens when I squeeze it. What happens to the volume of air in the Cartesian diver? Okay, I might be a little bit harder to see, but what happens is that volume of air actually decreases. The volume of water goes up and displaces the air, okay, causing it to actually dive down. Okay, so what am I doing when I squeeze the bottle to cause that to happen? Okay, so what am I increasing or decreasing as I did the squeezing to show and cause the volume of air inside that diver to decrease, causing it to get heavier and to dive down? So I could do this all day, and if you guys were here, it probably would be all day. So that is our Cartesian diver. Okay, here we are with our next demo for gas laws. So we're going to actually play with what we call an Erlenmeyer flask and a candle. And so I want you to think, what things are changing? What is being held constant? What equation could I be demonstrating? All right, so let's go ahead and let's take a look. So we have here in this plate, okay, we have our candle and we have some colored liquid. Okay, and so what are we going to do? So we're going to go ahead and the first thing we're going to do is we're going to light the candle. Okay, so let's go ahead and do that. Let's get our candle lit. So what am I doing? What am I adding here? What is changing? Remember, we're talking about our gas lab. I'm going to dip that in there just to get that out. So we're talking about gas lab. So the things that are changing are pressure, temperature, or volume. And we're dealing with only gas. So don't worry about the liquids. We're actually dealing with gas. So we're going to let that burn for about 30 seconds. We're going to get it nice and hot. Okay, so what is changing here? What is changing about the gases maybe in the environment or in the air? Okay. All right, so now what we're going to do is we're going to take our flask, and this is what we're going to do. Once it gets nice and warm, okay, we're going to take our flask and we're going to turn it over. Remember, there's air inside this flask, right? Air is always moving, constant colliding. It's always diffusing into here. So we've got a good amount of air in there, good amount of gas. I'm going to go ahead and make sure I don't have any liquid in here from when I was playing with it earlier. All right, here we go. So let's see what happens. So the candle, how is it changing the gas inside the flask? So what is it doing? So we're going to put it there. Let's watch and see what happens. Ooh, look at that. So what is causing it to happen there inside the flask? What is happening to the air? Because we're getting liquid that's getting sucked in. Okay, some of you may say a vacuum. You are correct. But what's happening either to the pressure or the temperature of the air? Okay, and now it's actually put out our candle, but you can see we've sucked up a lot of this liquid, displacing this air. So what's happening to the air? Okay, and which gas law did that? Just demonstrate. Okay, here's our next station for our gas lab. we are going to do balloon, and we're going to talk about volume. So we've got 2 balloons here, okay? I'm going to take one. I'm just going to go ahead and pour a little bit of water in it. Okay. Okay. So I've got my little bit of water there, and I'm just going to tie this off. So inside our balloon, think about what is 2 things are in there. Definitely have some water, some liquid, but I also probably have something else because it's not all water. So I probably have some gases in there as well. So we've got this balloon done. The second one we're going to do, here we go. We're going to also add some water. Okay. Add about the same amount of water. But the second thing we're going to add is an Alka-Seltzer, and I've kind of crushed it up a little bit. We'll do it a little more. Got it nice and crushed up in there, okay? And we're going to go ahead, and what we're going to do is we're going to put some of this, if I can make not a mess, would be nice, right? Okay, we're going to put some of this into our balloon. All right, and then I'm going to tie it very quickly, and then we're going to see what happens. Kind of want to set it down so I don't make too big of a mess, which I'm going to anyways here. So this is like an Alka-Seltzer tablet that you can see I'm making a mess already. And I'm going to try to tie it. Whoa! This is the one you guys would, it's so much fun in the room. Okay, I'm gonna tie this up. So what is happening? Okay, so this one has just some water in it. This one has that Alka-Seltzer and some water. What happens when you put an Alka-Seltzer in water? Well, I'll show you what is happening. What is it making? So there's one right there. Put a couple that I did not, so you can see that is what's happening inside the balloon. So what is happening? What is coming out? Why is this balloon coming up? What is happening? It's also a little bit harder. Like this one's a little squishier too, right? So what is it making inside this balloon? Okay, the Alka-Seltzer. What do you notice it's making? Okay, then also think about look at the volume. What's happening to the volume of what? What is changing? I didn't add any more water, so the volume of what is changing? So what do you think is happening? Because this one's a little harder. Why is this a little harder? Why is it a little stiffer to push on? What is happening to the gases inside there, right? Okay. And what is not happening over here? Because this isn't changing at all. So that is our Alka-Seltzer and balloon experiment.
Okay, and welcome for another gas laws demonstration. Okay, we have our dynamic duo here, Ms. von Volkenberg and Mr. Herzog, to show you another example of these things you've been learning this week. So we have a little ice chest here, and we have a vat of liquid nitrogen, okay, which is extremely, extremely cold. This is what they use in like cryogenic freezing and such. And then run some experiments with this. Okay, this is not dry ice. Maybe you have some experience with that. But nonetheless is very cold. Okay, so there's Ms. von Volkenberg with the balloon. Yep. Take it away.
All right, so we have this balloon. Think about it. We've been talking about pressure, volume, and temperature. So we have this balloon. There's gases in it. If I shake it, there's nothing in it. There's no liquid. There's no nothing. So think about what those molecules are doing inside this balloon. And what is it doing when it's pushing out on this balloon? So what is changing? Pressure, volume, and temperature. Now, this is very cold. So I'm going to take this. I'm going to actually put it inside here. So think about, as I dump this into this very cold liquid nitrogen, what am I changing? about the gases inside this balloon. And if you can see, my hand is starting to go down, okay? And it's starting to shrink, okay? So think about, what am I changing when I put in the liquid nitrogen? When I change that, it's either pressure, volume, or temperature. What else does it change based on those gas laws? So I'm going to pull this out. I'm going to show it to you, okay? So now the balloon is flat. And if you can see it, it's not only that, but it's steaming, okay? And it's also crackling.
Look at the bottom here. Look at the very bottom of the balloon. Okay, you can see there's a little bit of liquid, okay, on the bottom of that balloon. See that sloshing? Okay, where did that liquid come from? Okay, see that right here where my finger is.
And as we hold this, you can see it's starting to actually come back. So you can kind of hear it, hopefully. Hear it, but it's coming back. It's actually what is changing now. And here's the crackling of some of that liquid air, okay? And now I've got, again, a nice bouncy balloon. So how did that happen? How did it come back to being now my big bouncy balloon? A nice bouncy balloon again, okay? Pushing on the edges. Now I'm going to put it in again to the liquid nitrogen. So again, think about what is changing. Remember those gas laws and the relationships. So you can see my hand, I can actually push down on the balloon. So you can see it's really starting to become almost flat. Okay, so what is happening? And there's a lot of crackling happening too. So if I let it go, you can see it's like a boat. Put something in it, right? Okay. And as I lift it out again, it's kind of crackling. Also, steaming again. And as it comes out, what's changing that's causing this balloon to reinflate?
Can we sit on the counter?
There you go. Okay. And you can hear that crackling. What do you think that is? Okay.
Ooh, look how cold that is.
Yeah.
It's frozen. That's where the liquid was. Okay, so what you saw there, okay, as we compress the balloon into the liquid nitrogen, okay, it caused the air to literally condense. And that liquid you saw, as Mrs. V said, was literally liquid air. We just liquefied air inside of this balloon. Okay, because that liquid nitrogen is so cold, okay, it takes the gas particles and slows down those particles, and so it changes state from a gas to a liquid. And then as soon as we take it out, when the balloon can access the temperature, the regular air temperature, it causes that liquid to then expand back into a gas, and you get back your balloon. Okay, so just a little example of gas laws, and in your write-up, you guys can try and determine which specific gas law governed this experiment. Now we come to the fun stuff. And here we have, okay, Mr. Sarkeesian himself to help us. We have a variety of objects here. Okay, one is a little bouncy ball. Okay, oops, lost my bouncy ball. We also have a tennis ball. Okay, we have a tangerine, and we have a regular old apple. Okay, these are just regular items. We haven't done anything to change them yet. So now we will add them to our vat of liquid nitrogen. Okay, give them a second to marinate in there, and then we'll see what happens. Ooh, that's fuller than I thought it would be.
Yeah.
So let's see what happens when we dramatically cool down common household items.
You might want these if you're going to hold them. They're a little cold.
It's boiling nicely, Mr. Sarkeesian. Looks good.
The stew is brewing. Be ready.
All right, here you go. Try the tangerine. That'll work.
All right, here's a tangerine.
was a soft,
Wow.
squishy tangerine a few minutes ago. All right.
Yep, completely frozen. So you can
All right,
see.
who's next?
Anybody else?
You can see. All right,
Opposite.
guys.
Oh,
Here's
look at it
the
already
apple.
cracking.
Oh yeah, it's right.
Jesus,
Here
way
we
to
go.
make a big mess.
That's muscle. That's the apple.
Wow.
So that's what liquid nitrogen dropping that temperature does.
Time. Tennis ball. Ready.
But stuff came out. Liquid, look at liquid water's all over the table. Or liquid air.
Okay, so this is what should happen to the tennis ball. Okay. All right, there we go. Tennis ball broken in half with the assistance of liquid nitrogen.